Hey guys, we're going to pick up on frames and machines. We talked about trusses in the last couple of sections. We did method of joints and method of sections. And now we're going to switch over and look at frames and machines. To get started, we're going to talk about two force members again. We talked about these when we did the truss problems. And remember, a two force member is going to be a member that has equal, opposite, and collinear forces. Now the shape of the member is not going to matter. So I could have a shape like this. We could have a point B here and a point A. And if this is a two force member, we would have FB and then we'd have FA. Right? So we'd have this. Now these are equal and opposite in direction, and they're collinear because they're on this same line. All right, so negative FA equals FB. Okay, so that would be one shape. You could have just a link or a bar. That could also be a two force member, just like that. And let's look at something closer to what we'll be seeing in this section. Let's say we have this L-shaped bracket right here. All right, so we've got this bracket. It's pinned here at A. We've got this point B right here, and there's a force applied at B, like that. Now this can be a two force member. Even though it looks nothing like these two things, this could still be a two force member. And the reason for that is, if we were to draw the free body diagram, we've got this force F right here. And now if we come down here to point A, the force here at this pin could be negative F. All right, so these are on the same line. They're equal magnitude but opposite in direction. Okay, so keep this in mind when we talk about two force members. Key takeaways: equal, opposite, collinear. Okay, now we can also have multi-force members. These are going to be members with three or more forces. So let's just draw something that looks like this. And here you could have more than two forces. Now this one shows us three forces. You could have more than three forces. Another type of multi-force member is going to be a member that has two or more forces and one or more moments acting on it. All right, so we'll have a mixture of both of these. We'll have the two force members, then we'll have the multi-force members. You'll see that when we get to the examples. Now let's go over what a frame or a machine is. When we talk about frames or machines, at least one of our members is going to be multi-force. All right, so it's going to be something like this that has three or more forces, or two or more forces with at least one moment. And frame and machine, they kind of have different definitions here. A frame is going to be a structure that supports applied loads. And typically when we think of a frame, we think about a structure that is fixed in place. All right, so it's not going to move. There's no movement, it's just fixed. A machine, on the other hand, it's still a structure, but this is going to contain moving parts. And the moving parts, the purpose of those is to transmit forces or couples from input values to output values. Okay? And we'll talk about this more when we do our first example. Now, how are we going to analyze these? First thing we want to do, we want to isolate each of the members and draw its free body diagram. All right, now the key here, we need each member. So if there are four members, you're going to draw the free body diagram for each one of those members. Now these members are going to be placed together, so with pins, for example. Because of that, since they are pinned together, we're going to have action and reaction. That's from Newton's third law. Okay, so we're going to have interaction of members. You got to remember to take into account this Newton's third law when we're doing our free body diagram. And lastly, it's always going to be kind of difficult to figure out what direction you should be assuming on your free body diagram, because you're going to have multiple forces. Okay, so if you can't tell what the direction should be, I still think it's easiest to start with positive directions. So I always just make everything positive. That's just the initial direction I assume, and I think that that is easier. Okay. So let's draw some examples up here before we get to our real example. So let's say we have something that looks like this. So we've got a bar here, and then it's going to have another bar attached over here, like this. Okay? Now, these are both pins here, for example. Actually, let's make this let's make that one a rocker. That'll be good. So let's have a pin, and then we'll have a rocker. Like that. And let's call this B, we'll call this A, and then C. So if I want to analyze this, what I would do is I would draw each of these members. We've got two members right here. One here, one here. We would do the Freebody diagram for each one. Okay, so here's the one on the left. And then here would be the one on the right. Now what we would do is we would put all the forces on here. So let's start with these support forces first. We've got this pin at A. By now we know that we have two forces due to a pin. I'm just going to assume positive directions. Now up here at B, these are going to be pinned together. All right, so the two members are pinned together. Since it's a pin, we're going to have an X component of force and then a Y component of force. So I'm assuming positive here. Now over on this one, we've got a rocker. So let's just put CY. And then up here at B, we have a pin. Now these 2 points right here interact because we have this thing pinned together. All right, so they're hooked together. They can't separate at that point B. That means you got to use that interaction or reaction, interaction, Newton's third law. So we need equal and opposite. All right, so that means we're going to have BX go into the left and BY going down. Okay, so we started these out positive, so on the second one we just put them in the negative direction. All right, so these are equal magnitude but opposite direction. They're going to be collinear because they're on the same line. All right. So those would be a couple of examples. And then just another one. If we've got something like this, let's think of some scissors where we have the two handles pinned together in the middle here. What we would do is we would separate these out. So we'd do each one. And then for the pin, you would take the first drawing, assume positive direction. Remember, these are pins, so we have AX, AY. And then for this second member, we have to have equal, opposite, and collinear. So now we would have AX going to the left, AY going down. Right, so this is how these two things interact. Okay, so keep this in mind because that's what we're going to do in our examples. I'll see y'all for the first example in the next video.